Last up for this worksheet is topic 5. Where we're going to evaluate expressions. So we've done this several times throughout this course. We have an algebraic expression. We want to evaluate it. That just means we replace all variables with given values and then simplify. Okay, so for part A, we have x plus y, and we're told to evaluate when x is 1/3 and y is 3/4. So I'm going to go ahead and rewrite x plus y, but I'm going to go ahead and plug in the fractions for each variable. So x is 1/3 and we want to add y, which is 3/4. So we need to find an LCD, okay? Now, as you get used to this idea of finding an LCD, sometimes the LCD will be obvious. Like this one is one that eventually will be really, really obvious. But if you still need some help, just either use the prime factorization table or listing out multiples. Either one is fine. So let's list out multiples here. So 3 times 3 is 3, or whoa, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. I think that looks good. Let's go ahead and prove it. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. We've got our LCD. So the LCD here is 12. So now we need to find equivalent forms of each of these fractions. So I need to rewrite 1/3 as some kind of 12th. So what would I multiply 3 by to get 12? Well, that would be 4. So I want to multiply the top and bottom by 4. 1 times 4 is 4. 3 times 4 is 12. Okay? Now let's do the same thing for 3/4. We need to rewrite 3/4 as something over 12. So you would have to multiply 4 by what to get 12? Well, that would be 3. So top and bottom by 3. 3 times 3 is 9. 4 times 3 is 12. So if we go here and rewrite this problem, we know 1/3 is equivalent to 4/12. 3/4 is equivalent to 9/12. So now I have two fractions that are equivalent to what we started with, but they have a common denominator. And as long as we have common denominators, we can add or subtract the numerators, in this case add. So 9 plus 4 is 13, and then I just keep the common denominator. So I get 13/12. A common question is, do you write this as an improper fraction or a mixed number? Either is fine. I would just leave it like this, okay? Part B, we have x minus y, and we're going to evaluate when x is negative 5/6 and y is 3/7. So let's go ahead and rewrite the problem. So we know x is negative 5/6, and we're going to subtract y, which is 3/7. We need an LCD, so let's go ahead and start listing out multiples. So let's see. 6 times 1 is 6, times 2 is 12, times 3 is 18, times 4 is 24, times 5 is 30, times 6 is 36, times 7 is 42, and I'm going to stop there because I think that's going to work. 7 times 1 is 7, times 2 is 14, times 3 is 21, times 4 is 28, times 5 is 35, and times 6 is 42. Okay, so we know now that the LCD is 42. So let's get equivalent forms of these fractions. So I've got negative 5/6. I need to rewrite that as something out of 42. So you always ask yourself, what do you multiply the denominator by to get the LCD? So what would I have to multiply 6 by to get 42? Well, I would have to multiply by 7. And if I multiply the denominator, I have to multiply the numerator by the same thing. So negative 5 times 7 is negative 35. Now for the second fraction, we had 3/7. So I need to rewrite 3/7 as something out of 42. So same deal. What do I multiply 7 by to get 42? That would be 6. So top and bottom by 6. And in this case, 3 times 6 is 18. So let's rewrite the original problem. So the original problem was negative 5/6 minus 3/7. But we want to replace those values with equivalent values that have the same denominator. So 5/6 is equivalent to negative 35 over 42. And 3/7 is equivalent to 18 over 42. And anytime I have like weird sign stuff, I just let it all float to the numerator and I figure out what all that stuff is over the common denominator. So for now, I have negative 35 minus 18 over 42. And we can do a completely separate problem for negative 35 over 18. So we know from our work with integers that we can rewrite this as an addition problem. First integer stays the same. And then instead of subtracting positive 18, I want to do the opposite of both. The opposite of addition, or of subtraction is addition. The opposite of positive 18 is negative 18. So we're adding two numbers that have the same sign, which tells me to just add. So if you, again, if you need to do side work, do side work. So we get 35 plus 18. Well, let's see, 8 and 5 is 13. So I keep a 3, I carry a 1. 1 plus 3 plus 1 is 5. So that tells me this is going to be 53, but since both of those numbers were negative to start, my final answer is going to be negative 53. So over here, I get negative 53 over 52. And again, just leave it improper. Okay, so there you have it. That's evaluating algebraic expressions where the replacement values are fractions that have different denominators. So make sure you understand how to find an LCD. Make sure you know how to find equivalent fractions. Okay.